Welcome to the another video. So today in this video we will discussing about a small numerical of Thevenin's equivalent circuit. As you can see in this video, there is a 8 ampere current source is there. It is connected to some resistance like 10 ohm, 20 ohm, 50 ohm and 40 ohm. And these two terminal given A and B, we need to find out the Thevenin equivalent circuit across the terminal A and B. So actually in between A and B we could connect a load. So when we calculate the Thevenin's equivalent circuit, first we need to remove the load, then we need to find out the R equivalent or R Thevenin, then across that terminal we need to find out V Thevenin. So in this circuit already they removed the load and they asked just find out V Thevenin and R Thevenin. So when we will go for the R Thevenin calculation or R equivalent calculation, so at that time what we need to do? We need to open the current sources and short circuit the voltage sources. As here 8 ampere current source is there, so we need to remove the current source and redraw the circuit. So by redrawing the circuit, you can see here the current source is open circuited, so the current source will totally open. So just I am removing the current source. So what left only? So here 10, 20, 50 and 40 is removed. So if you calculate the equivalent circuit across A and B, so you can see here this 10 and 20 are in series, and here 50 and 40 are in series, and they are both together, they are parallel. So redrawing this diagram again, we can write down like this. So this is your A. So I will get 10 and 20 are in series and 50, 40 are in series and both are parallel. Okay. So we will get 30 here. So we will get 30 here. Similarly, we will get 90 here. Okay. So if we find out the R Thevenin or R equivalent circuit across A and B, I can find here 30 parallel with 90. So it will give here 90, it will give the 30. So I can write down here 30 multiplied by 90 divided by 90 plus 30. So we will get around 2700 divided by 120. So we will get around 22.5 ohms. So I can write down here I am getting R Thevenin equal to 22.5 ohm. Okay. So once I got the R Thevenin, then we can write down the V Thevenin. So when we calculate the V Thevenin, then we need to keep the current source or voltage source as it is. So you can see here we have a 8 ampere current source. This is 8 ampere current source is connected in this way. Let me draw the circuit. Okay, so you can see here this is your 10 ohms, this is your 20 ohms, this is your 50, I think. This is 50 and this is 40, right? Okay. This is your 50 ohms, this is your 40 ohms. Okay. So this is the terminal A, this is the terminal B. Okay. So you can see here, if we will see in the current point of view, you can see here this 10 and 50 are in series and here 20 and 40 are in series. So if you add this 10 and 50, I will get 60 ohms. Here 10, 20 and 40, I will get again 60 ohms. So let me redraw the circuit again. So I will get a circuit like this. Okay. So here I will get 8 ampere, here it will get 60 ohm, here I will get 60 ohm. That means this 8 ampere current will start from here. This 8 ampere current will start from here. When it reaches here, so as both 60 ohms are in parallel, so current will equally divide. So here I will get, here 4 ampere current will go, here also 4 ampere current will go. Now I will go to the main circuit. So here 4 ampere current will flow, again here also 4 ampere current will flow. Same 4 ampere current will flow through 10 ohms as well as 50 ohms. Similarly, this 4 ampere current will flow through 20 ohm as well as 40 ohm. When the current will flow, let me draw the circuit again. So let this is the circuit, this is the 8 ampere current is flowing. Okay, so let me draw the circuit again for you. Okay, so here the circuit is like this. So it is 8 ampere. Okay, this is your A, this is your B. Okay, so this is your 10 ohms, this is your 20 ohms, this is your 50 ohms, this is your 40 ohms. Okay, so as in the previous circuit, I find out this is your 8 ampere current, and 8 ampere current will divide here. This will be 4 ampere, this will be 4 ampere. So 4 ampere current is flowing from top to bottom. When the current will enter here, this will be plus, this will be minus, this will be plus, this will be minus. Same thing when current will enter plus, leaving minus. So there is a volt. Due to this current flow, there is a voltage drop. So let the voltage drop here due to this 4 ampere current. So I will get the voltage drop here. So what is the voltage drop? I will get 4 into 50. So let the voltage drop across 50 ohm equal to current flowing 4 into 50. I will get 200 volt. So I will get here 200 volt. Same thing we can check here. The current is flowing 4 ampere. The voltage drop across 40 ohm also. So current flowing 4 and the resistance value is 40. So I will get 160 volt. Okay, so here I will get 160 volt. Okay, so you can see here the voltage across 50 ohm. I can take this is plus, this is minus, and voltage across 40 ohm I can take this is plus, this is minus. Okay, so you can see here voltage across 50 ohm is nothing but the voltage across A. So when I have already told, when you are calculating the voltage across any terminal, that is always we are calculating with respect to ground. So you can see here the voltage across A is nothing but the voltage across 50 ohm is nothing but 200 volt. Similarly, voltage across B is nothing but the voltage across 40 ohm, and it is 160 volt. And they asked to find out the voltage across AB. That means voltage across A minus voltage across B. So I will write down 200 minus 160. I will get 40 volt. So voltage across this is 40 volt. So in this way you can count like this is the voltage across A and this is the voltage across B, and always calculating voltage with respect to ground. So in this way I can find out the V Thevenin is nothing but the VAB is nothing but 40 volt. If we draw its equivalent circuit, I can write down like this. So this is your equivalent circuit. This is your V Thevenin equal to 40 volt, and this R Thevenin. So R Thevenin is nothing but your 22.5 ohms, and you can say this is your terminal A, this is the terminal B. Okay. So in this way you can find out what is the V Thevenin and R Thevenin. So here the trick is that if they asked the voltage across any 2 points in between, so this voltage is nothing but the voltage across the ground, voltage with respect to ground. Similarly, voltage across the point B is the VB, that is with respect to ground. Or there is another way you can do in this way also. Let me do another way. You can see this is the terminal A, this is the terminal B, and here it is 50 ohm is connected, here 40 ohm is connected. So I can write down here this is 50, this is 40. Okay, so this is 50 ohm, this is 40 ohm as I discussed. So here there is a plus minus, so here I got the voltage drop equal to 200 volt. So the voltage drop is 200 volt. Here also current is entered, this is plus, this is minus. Here I got the voltage drop is 160 volt. Okay, okay, so I need to find out what is VAB. I want to find out what is VAB. We can apply KVL here. So if you apply KVL in the clockwise direction, so VAB, that means this will be positive, this will be negative. I am going from positive to negative, so I will get minus VAB, then plus to minus, I will get minus 160 volt, then minus to plus I am going here, so I will get 200 volt equal to 0. So if will minus to plus, I will get plus 200 volt. So I will get minus VAB plus 40 volt equal to 0. I can find out here also VAB equal to 40 volt. So any way you can find out using KVL or using that the potential across any point with respect to ground, you can find out the same answer. So here VAB equal to 40 volt. Thank you for listening.